Can you see my screen?
Yes, ma'am.
Okay, so the first question over here is, two circles second, no? Two circles having measurement. Let me draw the figure only. Okay. Two circles are there having radii 5 centimeter, and one more circle is there like this, and the radius of this circle is 3 centimeter. Okay. Intersect at 2 points. Both are intersecting at 2 point, the way you can see in the figure itself, and the distance between their center is 4 centimeter. So the distance between their center, if this one is O and if this one is O dash, so distance between these two center, O dash, here I am writing, is 4 centimeter. Radius R1 of the first circle is given as a 5 centimeter. R2, the radius of the second circle, is given as a 3 centimeter. What else is given? Find the length of common chord. So here we have to find the length of common chord. The figure is not given in the like beside the question, figure is not given. We have to draw the figure by ourselves. Here it is clearly written that we have to find the length of the common chord. So common chord we have to draw in such a way that chord will exist for the first circle, and that chord will be there for in the second circle also. So we can draw the common chord like this. We can say AB is the common chord. Can you see it? Can you see the common chord?
Yes, ma'am.
Okay. Let me. Yes, Ifra, we are doing one question from the circle chapter only. So here the question says there are two circles. The radius of first circle is 5 centimeter. The radius of the second circle is 3 centimeter. The distance between both the center, like the first circle and the second circle, is intersecting each other at 2 point. The way I have drawn the circle, and the distance between both the center is given as a 4 centimeter, as I have written on the screen that OO dash is 4 centimeter. We have to find the length of the common chord AB. Okay.
Okay, ma'am.
Have you done this question? Question. So we can make a triangle like this. We can say this is also the radius of the circle. Can we say this is also 5 centimeter? Can we?
Yes, ma'am.
Yeah. And if AB is the chord, here we can say the point of intersection over here is, let's say, M. Okay. So we are having a triangle AOM. Okay. Here what we can say, just a moment now. We can use the Pythagoras theorem over here, because we know that in a circle, if we will drop a perpendicular from the center on the chord, that perpendicular will bisect the chord. Do you know that? Do you know that? If we will drop a perpendicular from the center on the chord, that perpendicular will bisect the chord. Do you know this theorem? Have you discussed, like, have you done this theorem in the previous class? No? Okay, let me come on the screen. Let me check till where exactly you have done. From there, I'll be starting. So, the circle terminologies, like what is the tangent, like how many tangents we can draw, and what is the sector of the circle. Just a moment, let me check what exactly is there. Do you know what is the difference between segment and the sector of a circle? Everyone? No? Please unmute yourself, anyone. Otherwise, I will start from the very beginning. Yes, Ifra, Yatika, Rumaisha, Rehab. Let me know. Do you know that?
Ma'am, I can't hear you.
Am I audible? Yes, can you hear me?
Yes, ma'am.
Rumaisha, Yatika, rest of the student, are you able to hear me?
Yes, ma'am.
Okay, so please let me know that whether, like, I need to start from the very beginning, or you, the theorem which I am telling, that whenever we will be dropping a perpendicular from the center, it will bisect the chord. Do you know this theorem? No. Okay, let's
No,
start.
yes, ma'am.
Yes or no?
Yes, ma'am. We discussed these theorems.
Okay, this theorem you already know. So we are going to use this theorem only. Let me write the theorem so that you will be, like, able to connect with the theorem. Yeah, let me share the screen. So the theorem says the perpendicular from the center of a circle to a chord bisects the chord. So basically, this theorem says that whenever we will draw a perpendicular, suppose we are having a circle like this. Okay, this circle is having center, let's say O. Okay, and there is one chord. Let's say the name of the chord is chord MN. Okay, so the perpendicular we will draw from the center of the circle, from this center. If we will drop the perpendicular, that means 90 degree. If we will drop a line like this, this line, let's say OP, it will bisect the chord. The chord MN is getting bisected. That means the chord MN is getting cutted into equal part. Okay, if total length of the MN is 6 centimeter, if total length is 6 centimeter, then once we have dropped the perpendicular, we can say this is 3 centimeter and this is also 3 centimeter. That's what the theorem says. If you will drop a perpendicular from the center on the chord, that perpendicular will bisect the chord. How we are getting this theorem? Just by the concept of congruency, you will be able to prove that your the triangle OMP and the triangle ONP both are congruent triangle. Easily you will be able to prove. And once you will prove these two triangles are congruent, then you will be able to say that MP is equals to NP or PN. That means the chord is getting bisected. How we will prove this theorem? Very easily, by using the concept of congruency, we will be able to prove this theorem. If you want to see the proof, so that you will be able to just recall whenever we have to use this theorem, let me show you the proof also. So how we will do the proof? If we will take this two triangle, we know this is radius of the circle. Can I say OM is the radius of the circle and ON is also the radius of the circle? Can we say? Yes or no? OM, this is the radius. Can we say? And this is also the radius of the circle. OM, ON, these two are radius of the circle. Can we say? Yes or no?
Yes, ma'am.
So we will say that OM is equals to ON. Why? Because both are radius of the circle. We also know there is a common side, that is OP, which is common in both the triangles. And we can see here we are having 90, since we are dropping a perpendicular from the center, so 90 degree we are having in first triangle, in the left hand side triangle, and 90 degree we are having in the right hand side triangle. So that also we can use the information for proving the congruency of triangles. Why we are going to prove the congruency? So that we can prove this theorem. So we can say that angle OPM over here is equals to angle OPN over there. Both are 90 degree. Why both are 90 degree? Because we have dropped the perpendicular. Now that perpendicular is going to bisect or not, that we don't know. We have just dropped the perpendicular. We can see here which congruency criteria is getting fulfilled. Let me check. So this side we have used. This side we have used. And this angle we have used. I believe here RHS is getting fulfilled. Right angle, hypotenuse, and one of the side. Can you see that? So we can say that triangle OMP is congruent with triangle ONP. And from this, once we have proved these two are congruent, we can say MP over here is equals to NP over there by CPCT, and hence our chord MN is getting bisected. This theorem only we are going to use in our question. Okay. So let's use that. So I'm saying that here we are, let me write the question here, so that you will be able to understand what exactly the question is saying and what exactly we have to prove. So here the question says, this theorem is clear to everyone, right?
Yes, ma'am.
Two circles of radii 5 centimeter and 3 centimeter intersect at 2 points, and the distance between their center is 4 centimeter. Find the length of the common chord. This is what the question says. Figure is not given. So first thing first, we will draw a figure. Okay. So like this exercise is having very few questions. 4-5 questions are there, but you need to understand each and every question very properly. Okay. So here the question says there are two circles. Let's draw it. One circle I have drawn and one more circle I am going to draw. Okay, two circle of radii 5 centimeter, 3 centimeter intersect at 2 points. So we have to draw two circle in such a way that both are intersecting with each other at 2 points. So that's why I am drawing another circle like this so that both are intersecting with each other at 2 points, as you can see in the figure itself. So one of the point I can say it's A, another point I can say it's B. Okay. Now, what we have to find? The distance between their center is 4 centimeters. So if here we are having the center, let's say O. Here we are having the center, let's say O dash. So distance between these two, O dash, this is 4 centimeter. Okay. O dash is 4 centimeter. We have to find the length of the common chord. So we have to draw a common chord over here. We can draw the chord like this. And we have to find the length of AB. Okay. Now here we can say that let's say this point is M. So here we can say AM and BM both will be of same length. Why? Because once we are dropping, let's say this one is a straight line, we are dropping a perpendicular from here, a perpendicular, and this perpendicular will bisect our chord. If you will focus on this circle only, if you will focus on this line only, you can see here AB is there, M is there, so AM BM both will be same. So if we will find AM, easily we will say BM will also be same, and total length AB easily we will be able to find, right? And the radius of both the circle is also given. The first circle is having the radius 5 centimeter. Here this is 5 centimeter. The second circle is having radius 3 centimeter. Now we can use Pythagoras theorem for triangle AOM because it's a right angle triangle. So easily we will be able to use the Pythagoras theorem. So triangle AOM we can take and we can use the Pythagoras theorem. Similarly, we can also take triangle AO-M and we can use the Pythagoras theorem. Let's see how. So this distance AM, we don't know what exactly that is. Okay, let's write it as it is. So hypotenuse square, that is OA square, is equals to AM square plus OM square. This is what we can write according to Pythagoras theorem. Now OA square, 5 square is equals to AM square. We don't know what exactly is AM square plus OM square. OM also we don't know. The total distance OM, O dash M, that we know, but OM we don't know. Let's keep it as it is for now. Okay, now only we will make a equation and we will solve that. In the second condition, in the triangle O dash M, again we will apply the Pythagoras theorem. Let's do that. So hypotenuse square, that is 3 square, is equals to O dash M square plus AM square. Is it clear so far to everyone?
Yes, ma'am.
Okay. Now OM plus O dash M, we know that is 4 centimeter. The distance between both the center is 4 centimeter. Okay. Let's replace AM from here and AM from there. So AM square over will be 25 minus OM square. Equation number 1. And here AM square will be 3 square, that is 9, minus O dash M square. This is equation number 2. Again, I am repeating what we have done over here. Nothing. Radius was given. We were getting two triangles, two right angle triangles. So we have just applied the Pythagoras theorem for both the triangles. For the left hand side triangle, for the right hand side triangle. While applying Pythagoras theorem for both the triangle, we can see AM square. We are having AM square over there. We are having AM square over here. Oh yeah, we can compare both AM square and maybe we will get one equation which will be solvable. Okay, let's see that. So from equation 1 and 2, I am going to compare AM square. Okay, so I can write from 1 and 2. (25) minus OM square is equals to 9 minus O dash M square. Now we know one relation, this relation, that OM and O dash M together is 4 centimeter. Distance between both the center is 4 centimeter, written in the question itself. Okay. So we can say OM is equals to 4 minus O dash M. Okay. So let's replace OM, this OM, with O dash M. So we can say this is 4 minus O dash M whole square. Here we are having 25. If O dash M, we can say it is X. Okay. So at the place of O dash M, I am going to write X in the next step. So I can say this is 25 minus 4 minus X whole square is equals to 9 minus X whole square. Once we will expand it, we will get a quadratic equation. Let's see that. So 25 minus A square minus 2AB plus B square is equals to 9 minus X square. Here we will be having, let's open the bracket, due to this negative sign, each and every sign, due to this negative, each and every sign in the bracket will get reversed. So 25 minus 16 plus 8x minus x square is equals to 9 minus x square. Minus x square over here, minus x square over here. It is already getting cancelled up. Okay. Once you will keep it in one side, it will just cancel each other. Is it clear so far to everyone? What exactly are we doing over here?
Yes, ma'am.
Clear? Let's move ahead. 25 minus 16. 9 plus 8x is equals to 9. Wait. Are we missing anything? (25) minus OM square, 9 minus O dash M square. We have compared 25 minus OM square over here, 9 minus O dash M over here. Now OM and O dash M together is 4 centimeter. So we can say OM is 4 minus O dash M. If I am saying O dash M is X, A square minus 2AB plus B square is equals to 9 minus X square minus 16 plus 8X. Yeah, we have written it correctly. Why it is coming 0? If we will, instead of O dash M, if we are substituting OM is equals to, if we are substituting for the other one, let me check that. Okay, so 25 minus OM square is equals to 9 minus 4 minus x whole square. This is also x. If we are taking x to this one instead of that one, so 25 minus x square is equals to 9 minus 16 minus twice AB, 4 2 times 8, plus 8x plus x square. So we are having 9 minus 16, that is negative 7, plus 8x over here, and there we are having 25. 8x is equals to 32, x is equals to 4. Yeah, we are getting from here, but why we are not getting from there? Are we doing any mistake? If total is 4, and if I am saying this much is x, so this will be 4 minus x. Yeah, here we are getting 9 plus 8x, and there also we are having 9. Any sign mistake are we doing? Anyone? Are we doing any sign error? AOM, hypotenuse square is equals to AM square plus, yeah, we are, this way also we must get it. We will get back to this one. However, while taking the other way, that is, if I am saying that OM, this one is x, OM is x. Just look at the figure. Can you see it? OM. If I am saying that OM is x, that then O dash M will be 4 minus x. Yes or no? If this total length, if this total length is 4 centimeter, and if I am saying that OM, this much only is x, then remaining will be 4 minus x. Yes or no? Are you getting it? If the total length is 4 centimeter and a part of it is x centimeter, then the remaining will be total minus x. Yes or no? Are you getting it? Suppose I am having the total as 100 rupees. Okay. I am giving a part, like let's say I am giving 20 rupees to one of you. I am giving 20 rupees to Yatika. Then remaining will be 100 minus 20. Yes or no?
Yes.
Similarly, if here I am saying total length is 4 centimeter. Okay. and from here one of the length is a part of it, OM, is x centimeter. Then the remaining length will be 4 minus x. Yes or no? Are you getting? So similarly, I have taken that 25 OM I have taken as a x centimeter. Remaining, that is O dash M, became 4 minus M. 4 minus x. Okay. And once we are solving it, just focus on the red one, red part. Once we are solving it, that is 25 minus x square is equals to 9. And here we are expanding it. A square minus 2ab plus b square. So minus 16 plus 8x. This will be minus x square. Okay. Once we are expanding it, we are getting this expression. After that, we are getting 25 is equals to negative 7 plus 8x. From here, we are getting x value as 4 centimeter. Okay. But total was given as a 4 centimeter. That is also one of the case. Okay. So why are we getting this? Because yes, here it will come out as a 0. X value we were getting as a 0, and that was correct. Here we were getting x value as a 4. Yes, we are getting it correctly. Okay. So basically in this question, this O dash point and this M point is the same point. That's why we are getting such data. In one of the, like, once we have solved the first way, we got x value. We were getting x value as a 0, and we were thinking, why are we getting x value as a 0? Yes, x value will be 0 over here. Why? Because we are saying that this is O, this is O dash, here we are having M. Okay, we are saying the total length is 4 centimeter. This much is x centimeter, the remaining will be 4 minus x. Once we are solving it for x, we are getting x is equals to 4. Why? Because this O dash point, and this M point, it's the same point. That's why we are getting such data. Are you getting it? O dash and M are lying on each other. That's why we are getting x value as a 4 after solving. Are you getting? Or in first case, we were getting x as a 0. In the first case, what I have assumed? I have assumed that O dash is there. Here we are having point M. Here, let's say this is x. So this will be 4 minus x. So we were getting x value as a 0 in the first case, and we started thinking, why are we getting 0? We are getting 0 because O dash and M is the same point. Is it getting clear? Anyone there? If I am saying that O dash and M is the same point, are you getting it? Why are we getting x value as a 0 in the first case? Please respond. So we can draw the figure like this. There is a circle like this. There is another circle like this. Let me see the question. Here, the first circle is having the radius 5 centimeter. The second circle is having the radius 3 centimeter. The distance between both is given. We have to find the common chord. This Basically, we want to say that O dash and M is the same point, and our figure will look like this one. Here only O dash will lie, and we have to find the distance AM. Our figure will be like just if we will draw a triangle, this O dash and O you say or M you say, it's the same thing. We know this is 4 centimeter. We know here radius of one of the circle is 5 centimeter, and we wanted to find this AM. Initially, we said that AM, BM both are same just by the previous theorem that the chord is getting bisected. So if we will find AM only, we will be able to say that is only the BM, and both will be added together to give the length of the chord. So this is how our triangle will look like. This is how our triangle will look like. It is nothing but just a straightforward right angle triangle where we have to find AM. Can you see it? Once we started solving, we realized that O and M is the same point. Why? Because we got X value as a 0. Okay, that means it is nothing but just a straightforward right angle triangle where we have to find AM by using Pythagoras theorem. Okay, once we will find AM, we can say AM, BM both will be same, and both will be added together to give the total length of AB. Let me summarize the whole thing. We were having two circles over here. Okay, there was a common chord like this. We wanted to find the length of the common chord. What information was given? The information was given as a, this radius was given as a 5 centimeter, this radius was given as a 3 centimeter, and the distance between both the center, that is O and O dash, was given as a 4 centimeter. This much information we were having in hand. We wanted to find the length of AB. What we did, we said that okay, AB we want to find, here is the point AM. We know AM, BM both will be same by previous theorem. So if we will find AM only, we can add AM plus BM and we can get AB directly, easily. Okay. So we just concentrated totally on finding AM. Okay, once we started finding AM by taking this triangle, that triangle, we realized that X value is coming out as a 0. Okay, what is X? This one we have taken as a X. In the first case, we have taken this one as a X, and this one 4 minus X. We realize that X value is coming out as a 0. So we can say O dash and M is the same point. That's why here I have drawn the triangle only separately to have a clear idea that O dash and M, it's a O and M is a, sorry, I want to say O dash and M is the same point, and we are just having a triangle where we want to find again AM, initially what we have decided. How we will find AM? Just by Pythagoras theorem. Let's do that. So AM, here hypotenuse square is equals to base square plus height square. Easily we will be able to find AM, that is 25 minus 16, and we will get AM as a 9 AM square. AM will be plus minus 3. We will be taking positive 3 only because we are talking about the length. So positive 3 we got AM. Now we want to find AB. So BM will also be 3 centimeter only, and we just have to add AM plus BM, that is 3 plus 3. to get the total length of AB. Is it clear now to everyone?
Yes.
Yatika, Ifra, is it clear?
Yes, ma'am.
So this is the whole process. Once we got 0, we started thinking that why are we getting 0? Once we are solving the equation, like how we are getting 0, then we realize, okay, it will be 0 only. Maybe the point O dash and is the same point. If you will check the answer, it will be given 6 centimeter only. This is how we will realize. First thing first, we will like realize that it's the same point. It's not written in the question. You can read the question. Anyway, you have to do the whole process to show that x is coming out as a 0, and that's why you are just applying the Pythagoras theorem directly to find the value of am. Okay, so if you are thinking that we don't need to do this much, we just need to do the last part, no, you have to do the whole thing to show that x is coming out as a 0 and o dash m is the same point. O dash and m is the same point. Okay, got it?
Yes, ma'am.
Let's move on. If we are having, if a line intersect two concentric circle with center O at ABC and D, prove that AB is equals to CT. Okay, let me draw the figure. We are having one circle and there is one more circle. Concentric circle means both are having same center. How we will be getting such circle? So when you will take the compass and you will draw one circle by taking any radius, let's say the radius is 3 centimeter, 4 centimeter, you will just take a radius and you will draw a circle. Now you will just keep the needle of the compass at the same point without moving the needle. If you will just stretch the arc, that means now you are going to take the radius. Previously you have taken 4 centimeter, now you are going to take maybe 5 centimeter, 6 centimeter, 7 centimeter, 8 centimeter, keeping the center same. Okay, just you are going to keep the needle wherever you have just pressed it in the copy, same place you are going to keep the needle and just stretching the arc, making one more bigger circle. That way you are drawing concentric circle. Okay, a two circle having the same center with center O. Here center O is there. However, figure is given in the question itself. Here we are having A, here we are having B, here we are having C, and here we are having D. If a line intersect two concentric circle with center O at a point A, B, C, D, prove that. We have to prove that A, B, and C, D both are same. Anyone? How can we do so? Anyone from here? Now only we have discussed one theorem. Can we use that theorem over here? If we will drop a perpendicular from here, what can we say? Let's say this is M. Yes. Ifra, Yatika, who else is there? Umaisha is there. And only 3. What can be done? Can I say that for the smaller circle, if we will drop a perpendicular, just focus on the smaller circle. Let me draw it separately. Just focus on this smaller circle, the inside one. Here the center O is there. Here the chord is there, BC. And if we will drop a perpendicular OM like this, can I say BM and CM both will be same? Just by the previous theorem, can I?
Yes.
Yeah, we can. And if we will focus on the bigger circle, just on the bigger circle now. Okay. So here, if there is a chord that is AD, and if we will be dropping the perpendicular, I am talking about the same perpendicular, OM. Okay, this is the perpendicular. So can I say AM and DM both are same? Yes or no? Just by the previous theorem,
Yes,
because that
ma'am.
theorem is applicable for any circle. Yeah, anyone saying anything?
Right.
Is it getting clear?
No, ma'am. Yes, ma'am.
Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So A and DM both are same. Similarly, for the smaller circle, BM, CM both are same. Now, if we will subtract it, let's say this one is equation number 1. This one is equation number 2. If we will subtract 1 from 2, 2 minus 1, if we will be doing like that, that is AM minus BM is equals to DM minus CM. If we will be doing like that, then what we can say? AM minus BM. Focus on the figure. AM minus BM will be what? Anyone, please tell me. AM minus BM is what?
AB. AB.
AB? Yes, it's AB.
AB
Perfect.
is equal to
DC. What we wanted to prove? Let's see. This is what we wanted to prove, right? Is it
D.
clear?
Yes, ma'am.
Yes, ma'am.
Okay. Let's move ahead. I'm giving one question. Do try this question and do let me know in the next class that whether you have tried or not. We will be discussing, of course. But first, each and everyone is going to tell me whether you have tried it or not. Okay. And what approach you have applied. So the question is a circular park. Write it with me. Is of radius 20 meter, is situated in a colony. 3 boys, Ankur, Syed, and David, are sitting at equal distance on its boundary. Each having toy telephone, for talking with each other. Find the length of a string. Find the length of a string of each phone. Okay, a circular park is there whose radius is given, is situated in a colony. 3 boys are sitting at equal distance on its boundary. So basically, the figure will look like this one. A circular path will be there and three boys are sitting. So let's say this is one of the boy, this is another boy, and this is the third boy. Three boys are sitting like that. The name of the boys are Ankur, Sayed, and David. So here one of the boy is sitting as a Ankur, another boy over here is sitting as a Sayed. Here David is there. Just like this, three boys are sitting on the boundary. Okay. Now all are sitting at equal distance on its boundary. So this distance, and this distance, all are same. This is x, this is x, this is x, all are sitting at a same distance. Okay. Yeah. Find the length of string of each phone.